Okay, people, so if you haven't met me before, my name is Josh. I was a computer science examiner. I was a head of computer science as well. And what we're going to be going through today is the Edexcel 2023 paper 1. And we're going to walk through all of it, and I'm going to show my experience, tell you how to get better at this exam board. So let's go for it. So the CPU contains a number of components. Complete the table with the correct bus for each role. So it says carries a read signal to the main memory. So this is going to be the control bus, this is. So we're going to write in control bus. I'll make that a touch bigger. There we go, that's a bit better. Okay, next one. Carries a memory location of a piece of data. So memory location, if you think about that, that's an address. So that's what the computer uses to actually understand what it's doing. So if we go in here, address bus, then the last one, because there's only three, carries an instruction from main memory to the CPU, data bus. Okay, so remember data bus carries instructions and data from main memory to the CPU. Identify the component inside the CPU that stores data. So we've got the arithmetic logic unit, the clock, the main memory, and then a register. Now the trick that they're trying to play on us here is obviously what we've got is you might be tempted to go with main memory. That's actually not inside the CPU, so it'd be a register. If they said cache as well, I'd be tempted to maybe go for that, but they haven't got that there, so we're not going to go for that. So let's go on to page 2. State the there we go. Algorithms can be written in high-level language. State what high-level code is translated to. Machine code, which is the zeros and ones. State 2 methods of source code translation. So with the source code translation, so you've got translators which can do that. So you can go interpreter, and you can also go compiler, interpreter, which that does it line by line. And we're going to go compiler. So those are the two ones. If it was said assembly language, if it was talking about assembly language, I'd maybe be thinking about that as well. And then you could do an assembler in that one as well. So for the next part here, it says identify the feature of an optical disc that allows data to be read. So it's magnetic, it's portable, it's reflective, it's volatile. Magnetic, optical discs are optical, so that's not correct. Portable means it can be moved around, so that's nothing to do with it being read. Reflective is the answer, because that's to do with when you shine the laser on it. When you reflect it, that's how it picks up the data of it being a 1 or a 0. Volatile means that when you turn the power off, that it forgets all of the data. So again, that's nothing to do with it. So that one there. Define the term embedded system. So the buzzwords that we're going to use on this one here is, so it's only a 1 mark actually, to be fair. So it's a computer system within a larger system with one job, e.g., like your printer, sorry, not a printer, like a fridge. If you think in a car, in a specific example like that, what you've got in there is you've got the GPS, you've got the automatic parking sensor, parking system. That's all an embedded system. Okay, a code review is carried out by a programmer or an automated system. Both methods cost money. Complete the table with one disadvantage for each. So a code review is just where we look at the code and we think to ourselves, so we can either get a programmer to do it or an automated system to do it. So you could obviously say with the programmer, a programmer will get tired and maybe make a mistake due to being tired. Another one, so if we said for the automated system, the automated system will only be able to check a system that based on the criteria it's being given. If it is outside of the criteria, it might miss errors. So it's like the automated system is only going to be working with essentially a system. So what the programmers that have programmed the automated system have told it to do. So it's like it's never going to get tired, which is great, but there is going to be the potential error of what we could do is it's only going to be given a set criteria, and then it might make an error based on what it's, if it's a little bit out there, the code that it's looking at, it might miss a few things in there. Identify the purpose of defragmentation software, which is a utility software, and essentially, so compressing software, it doesn't do that. It doesn't make the data less. It doesn't make the actual file size smaller. Encrypting means like making it unreadable, and it's not that. Organizing data, it does do that. Yeah, so it organizes the data so that then you do not have to, so that it essentially makes it quicker to read. And then protecting data, it doesn't do that, because that's more to do with like cyber security kind of stuff. Let's go on to the next page. One function of the operating system is to manage processes. Describe one way the operating system makes sure each process can use the CPU. So one of the ways that we can talk about here is a scheduling. Actually, that might be a little bit more A level. So we can talk about processor management. Actually, I was going to talk about processor management, where the OS will give a time slice to each process being undertaken. And when the time runs out, and if it hasn't finished the task, that task goes to the back of the queue, and the processor works on a different task. Okay, so it's like it will give it a set amount of time, and then once that time's finished, if it hasn't finished it, it will then send it to the back of the queue and then go through the other way. Okay, so the next thing, give one other function of the operating system. So we've got memory management. You've got user interface management. You've got peripheral management, which I guess you could call it driver management. So you've got loads of other ones that you could potentially use in that one. I think the next page is over here. I'll put it over here. Okay, so we've got question 2, which is about networks. Complete the diagram of the TCP IP protocol stack. So we've got application up at the top. And then we've got the transport layer here. Okay, scroll down. Name the network topology that uses terminators to absorb signals. So that is a bus topology, that is. So that's going to be a bus where it's got the topologies at the end, and it's a big long cable. Looks a little bit like this. Got big backbone cable in the middle, and then you've got your nodes coming off like this, which could be a server, it could be a printer, it could be a computer, all that ways. Identify the reason computers are connected in a network. So to improve encryption, that doesn't really make any sense, because it doesn't do that. To prevent hacking, going on a network, the kind of disadvantage of that is it actually increases the probability that you're going to be hacked, so it's not going to be that. To reduce latency. So latency is how quickly packets get over to another computer, so it's not to do with that. To share peripherals, yes. So that is one reason why we can connect to a network, and it's actually a really good thing to do that. Next page. State the network protocol used to request a web page. So to request a web page, you can do, so it's either going to be HTTP, HTTPS. You're going to be absolutely fine with that one. Explain one benefit to a user of using IMAP to access emails. Okay, so IMAP, the main advantage, because in comparison to POP3, so explain one benefit to a user. So we're going to state the reason, and then we're going to explain why it's good. Okay, so IMAP allows or keeps the email on the web server, meaning you can view it on multiple devices. The other way that you can read emails is you can use POP3. So other email POP3 does not allow for it to be viewed on multiple devices. So there's that one there. So it's all to do with that you can essentially view it on multiple devices because it doesn't delete it off the web server. Factory has 2 file servers installed in the office. A closed circuit television system monitors the factory. Explain one other method of physical security that could protect. So a closed circuit television. So we could, essentially what we can say is like locked doors. You could say maybe you could have staff there. I mean, I'd probably go with something like biometrics. And where you have fingerprint scanners. They're fingerprint scanners at the doors to access the servers. Okay, next one. We've got define the term bandwidth, the amount of data in bits that can go onto the network per second. So if you can actually do a speed test. So if you go into Google and type in internet speed test, it will tell you how quick your bandwidth is. So if you just type in internet speed test into Google, there's a little option where it will just come up and then you can check how quickly your internet is working. High-speed fiber optic cables form the internet backbone. Routers connect other networks to the backbone. Describe how a router enables data to arrive at its destination. So it's 2 marks there. So routers. Describe how a router enables data to arrive at its destination. Okay. Routers have a table of devices with the IP addresses that are connected to the devices based on their MAC address, and then they send data packets to those devices maybe forward data packets to those devices based on the IP address. So it's got a table. So each device has a MAC address, which is a specific address that is given to the device. And then what it's got in there as well is it's got the router then gives it an IP address, which it keeps a table like this MAC address belongs to this IP address. And then when it receives a data packet, so if I was sending you something over the internet, the data packet would have on there that it needs to go to this specific one, and the router forwards that data packet to that device based on that. So that's all good. Let's go on to the next page. So we're on to the next question, which is issues and impact. Computer worms are a type of malware. Describe one way that a worm can move from a machine to a machine. Okay, computer worms are a type of malware. Describe one way that a worm can move from machine to machine. So how they get sent around is emails. So buzzword that you need to say is worms are self-replicating. I don't know why they like that so much, but they do. That gives you 1 mark, and say, and it can copy itself to other people based on sending itself through emails. Okay, so that's how it kind of goes around. So it's, you don't necessarily, a worm can send itself around, which kind of makes it a bit of a unique virus on there. The source code of a software application is automatically copyrighted. State one other method of intellectual property protection to control who can use software application licensing. It just means if you've got a license to do something as well, so that's there. Computer programs control airplane landings. Explain one reason why computers are not capable of safely controlling all airplane landings. So it's 2 marks here. This is a bit of a weird question because it's like you've got to think about of the essentially why might something essentially go wrong based on the computer system. So there's a few things that we could do about. I would have thought it's probably to do with like updates, potentially if it's hacked. So if it's that was something. So update it has. So the software may not have been updated is always a good place to start. And in this case, I'd probably be tempted to go for as well. Did it say explain one? are not clear. So yeah, that was a little thing there about exam technique. So I can't just list two of them, and then get 2 marks. The what, because it says one, what I have to do is explain. So I have to describe one and then explain it to get the 2nd mark in there. So the software may not have been updated, which causes the sensors to not work correctly and cause an issue with landing. So it's like, link it to why that would actually cause a problem, because if it's not updated, maybe that would cause a bit of an issue between the two, maybe the sensors or something along those lines. So that's why you've got, I couldn't just simply just list the 2 different points on that. Okay, next one. Large amount of water are used to manufacture computer chips. Describe one way that this affects the environment. So with this one, again, it's about thinking about how this could potentially not be so good. So the water could be used to in places where they need to drink the water, and then causes a drought. So the water could be used in places where they need to drink the water and then causes a drought. This could then cause issues with people being able to access safe drinking water. So for this next one here, there are ethical and legal issues with collection and use of personal data. Complete the table with ethical and legal issue, with the ethical or legal issue for each situation. So it's not whether it's ethical or legal. You need to say like the specific. So there's like ethical things that are wrong with it, or legal issues that could be wrong with it. So let's have a little look. So it says an online learning platform publishes data about how students answer questions. So they've said like obviously the ethical issue there is like, have the people given consent? A teacher uses another teacher's login to change students' grades. So that there comes under so it's a legal issue, which is computer. You could say Computer Misuse Act or Misuse Act, because you're using a computer without somebody's essentially consent, and that's like you've broken into it and used that one. A school displays closed circuit television screens in a public area. So that, again, that's an ethical issue, which is going to be privacy issues, because it's the privacy of the students using it and how they get on. Programmers use trace tables. So what I'd be saying there is explain the purpose of a trace table. So not a truth table, because that's what I was thinking initially, but a trace table. Trace tables are used to check. So allows programmers to test how the program flows and test for any logic errors is the main reason, I guess it is. Yeah. That's probably what I'd be going for on those ones in there. So if we scroll down on the next one. Okay, for this question here, let's talk about, so it says describe a record which uses arrays and records. So with this one here, key buzzwords is it's going to be a list, contains multiple fields, that's kind of what it is, and they are related to the same topic in this one. Okay, if we scroll over to here, so we've got, an algorithm allows users to enter a whole number, the number can either be positive or negative. The purpose of the algorithm is to report whether the number is odd or even, okay? The modular function returns the remainder, so we're going to use mod. The algorithm can be expressed as a flowchart. Here are some symbols. Have I got any symbols in here? Because that would be really useful. Yes. Okay, let's try that then. So, so we've got start. So they've already done start and end ones for us. Now, they've actually given us all of those, which is really, really quite kind of them. I don't think I've got a parallelogram though. So be really careful with your parallelograms, because that's going to be the thing which they're going to be really checking. Okay, so What you might want to do is you might want to put on here, that's not working. So with the shapes, what I'll try and do is I'll copy and paste these, but as I was saying, be really careful in terms of how you draw them, because if you mess up the parallelogram, they will not be kind in that regard. So what we need to do is we need to get a number. Now you could obviously output, so you could just go and put output, enter a number, like so. And then we're going to draw a little line in between those. And then what we're going to do is then we're going to take another input, which is going to be another input box, and then we're going to input and then we need to get a variable. So if we put input num, okay, so we get the values from there. Then what we have to do is then we're going to do some kind of process where we're going to do answer equals. That's a bit big. Could put that there. And then what we're going to do is answer equals num mod, which is going to be the percentage. I mean, you could put mod, but it's in Python, it's the percentage sign. Mod 2, okay, and we are going to, just to double check, the purpose of it is to report whether it's even or odd. Okay, so if that answer, so if we mod that, so if we did, for example, 11 mod 2, that would give you 1 as a remainder. So if it's an odd number, it's going to give you 1. If it's 0, it's going to give you, it's an even number. So those are the two things. And then we've got to go to a decision. Is answer equal to 1. And then you're going to do 2 decisions from your decision. And then you're just going to do, what is it? Just double check if it wants you to like output anything. So does it just say return the modules? Okay, the algorithm. The purpose is to report whether, okay, that's fine. So then simply all we need to do is just output to them. Be careful not to use a process. Output. So if it's yes, then so if it is 1, it's odd. And then the other one. Output even. And then you just need to make sure that on the little lines here that you put like true or false, or yes or no, I guess is absolutely fine as well. So true, false. And then finally just connect it up at the end where we all finish. They're all done. Okay, so that's that done. Okay, let's go over to here. A linear search is an algorithm that can be used both on a sorted and unsorted array. Describe how linear operates on an unsorted way. So very important. I remember marking lots of papers on this one. A lot of papers when I was examining, and it's all to do with the words that you use. So it's going to be you have to, what some people would say is it goes through the list and checks every item. They don't like that. So what we have to do is we have to be really, really clear on what it's saying. So it starts at the very first item. It starts at the first item and checks whether that is the item you are looking for. If it is, it stops the search and outputs the item's position. So that would get us a couple of marks there. If not, it moves on to the next item in the list and repeats the same process in order. So you need to get this idea that it goes in order, and it will either find the item or not find the item, where it will output item not in list. Now, can you see how with that it's really important, a lot of the keywords that I've used there, to make sure that it's like I'm getting every single point in there, that the examiner fully understands that I understand what's going on in there. Okay. Algorithms control physical devices using logical operators. A security system turns on a floodlight when the sunlight falls below a certain level, S, okay? And a movement sensor is activated, M. Complete the truth table. So essentially what we've got here is they just want us to complete the truth table. So we're just going to do, so remember, a truth table shows all possible inputs to all possible outputs. Okay, and then it just says a security light turns on, so this thing is true when the sunlight falls below a certain level on S, so if that's true, and a movement sensor is activated, so it's just an AND gate. So it's going to be 0, 0, and it's only true when both of them are true. Don't know if that's, let's just have a look if that's the only thing on the page. Okay. A group of students are working together on a single maze game. The arrow keys control the character. When the character reaches the end of the maze without touching a wall, a happy sound is played. The game also displays a score. Discuss the use of decomposition and abstraction developing this game. Your answer should include a definition for each term, the benefits each brings to the group of students. An example of where each could appear in the program code. Okay. Let's break this down. So a group of students working on a single maze game. Okay, so we've got the single maze game. Great. There's arrow keys. When character, so the group, I guess, so that's getting at is that it's making a game. It's got arrow keys that are going to use it. It's got the maze game. When a character reaches the end of the maze without touching a wall, a happy sound is played. So then it's got those features where if it bumps into a wall, that's also, the game also displays the score. Okay, that's fine. Right, let's talk about that then. So, okay, so definition of each of them to start with. So abstraction is where we remove unnecessary details and focus on what is important. Decomposition is where we break a large problem down into smaller problems. Okay, now let's talk about the benefits of the benefits of each brings to an example of where it could be used in there. So a benefit of using abstraction is going to be not focusing. Benefit of using abstraction is if a group of students are focusing on the, let's say, the high score part, and there's another group focusing on the level design, they can ignore the other parts of the program and just focus on the part which is important, which they are working on. With decomposition, they could, so with decomposition, this will work really well because it will allow them to split the task up into more manageable parts, and then they can speed up the development time because they are working on a specific area. Okay, that's fine. And then we can also just say, okay, so abstraction will be used when libraries are called for different areas of the code, and decomposition is used when we make sub-programs. Okay, so then we've got definitions, benefits, and how it's going to be used in the code in there. Okay, let's go to the next part. So describe one effect of using lossy compression to reduce the size of a file. So what we've got here is it will permanently change the file by either reducing color depth / audio bit depth to reduce the size of the file. Okay, so that's there. Here's the original. There's one bit available to represent each pixel. Explain one reason why the image cannot be represented using one bit for each pixel. So I would say that so we've got a grey, we've got white, and we've got black. Okay, so one bit of data, if I was trying to zoom in a little bit more, one bit of data will only allow for two colors, and there are more than two colors. So they won't be all represented in that. Shifts are performed on bit patterns. A logical right shift is performed on the pattern. An arithmetic shift is performed on the same original pattern. Describe the reason the results will be different. Okay, so with a logical shift, so how logical shifts work. So if you imagine we've got like that. And let's say that you did, what is it talking about? Logical shift right is performed on a pattern. So that's, say you move everything to the right. In a logical shift, what happens is it just moves everything along. So that one in the most significant bit position, because that determines whether it's, if we're doing 2's complement, whether it's a negative number or not, that gets moved along, so that'll actually get changed into a 0. Okay, so that's changes the number. Now arithmetic shifts, they will always make sure that that bit stays consistent. So that's the difference between the two of them. So that is, in an arithmetic shift, that stays the same. So a logical shift is when we move the bits to the right, the most significant bit, you can use the shorthand MSB, will change from also I could probably say will change from a 0, or to change from a 1 to a 0. An arithmetic shift, shift will keep the MSB consistent, whatever it was before the shift. Okay, so that's the main difference between the two of them there. Binary, denary, hexadecimal patterns are used to represent it. So I would just say do not take any chances on this one here, people. So obviously just do your numbers. So we've got 1, 2, 4, 8, 16, 32, 64. So we've got 64 and 2, which is going to give us 66. For that one, obviously the furthest one over there is going to be 128. And binary patterns for this one here, so convert the binary pattern for this one over here. So split them into two separate nibbles. 1, 2, 4, 8. I mean, I probably should do this a bit bigger. 1, 2, 4, 8. I would also get into the habit of doing this. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. Why do I tell you to do that? Most people finish the computer science exam early, and so many people just guess what this number is, and they get it wrong because they think like B is 12. So just write that down because you've literally got it there, what it is. So let's do the one on the right-hand side. So that's going to be 8 plus 2 plus 1, so that's 11. And if we have a look at our little code, that's going to be B. So it's going to be B here. And then the other one is going to be 0, 1, 0, 1. So then that's going to be 1, 2, 4. So that's going to be 6. So it's going to be 6B is the answer on that one. Data storage is measured in bits and bytes. State the number of unique values that can be represented with 6 bits. So 6 bits, we do 2 to the power 6. So count on your fingers. So just start with 2 on 1, and then just you're going to go up from there. So 2, 4, 8, 16, 32, 64. File format uses 100 times a 600 table and a 32-bit integers. File uses 1 kilobyte of additional data. Okay, construct an expression to show the number of bytes of storage needed to store that. So it says construct it. Doesn't necessarily, the file uses 1 kilobyte of additional data. Okay. The calculation that you would do is something along the lines of like, so you're going to do, I'm assuming it must be a file, it must be an image. So, or something like that. Of the, oh, sorry, it's a table of 32-bit integers, and it's just saying like that's what we've got. So we need to work out the number of cells we've got. So the number of cells is going to be, so just stick those, so stick the zeros on the end over there. So we've got 60,000, and then you're going to times that by 32. Notice that it says construct an expression, okay, and so that's nice. So that gives us that. It means that we don't actually have to work it out. So we do that. That gives us the cells. Every cell has got 32-bit integer. We could, if you're getting a little bit extra technical, so that would then give us it into bits. And then what we can do is, so if we, what it's getting at here is it's also got an extra bit of extra kilobyte in there as well. So we're going to do that. Let's divide that into by 8, okay? So that's going to give us that part. And the sneaky little bit at the end there is we just got to add on 1024 onto that calculation. And that's going to give us the result. So we do that times 32 divided by 8. And then just once you've done everything there, then plus 1024 onto it, because that's going to give us that. So the 32, that gives us all of that. And it's just saying this is just an extra bit of data. We divide it by 8 because this gives us the amount of bits we've got, but we want it in bytes. We do that, and we also know that they've got an extra bit there of kilobytes, so that gives us the extra little bit of data in there. Okay. Right, I think the final question is just down here. Okay, let's have a look. An analog sound is represented in digital form. The sound is 1 second long and is sampled at 10 hertz. The digital representation has a bit depth of 5 and is stored in 2's complement. Okay, we've got the sound, so we've got to draw the labels for the x and the y axis, all that kind of stuff. Okay, right. Okay, so what we have to do on this question here is we're going to have to represent all of the different values in here, and we have to look at what are the different sounds that we can represent. We've got 0 here. Now the little thing here that it's got is 2's complement. So what it's going to tell us is these values here are going to be -1s, and I'll show you why they're -1s. So the 1 at the front signifies that we've got a negative number. That's the most significant bit. And if I needed to convert, let's say I had normal 1, yeah, I go and find everything at the first 1 and before it stays the same. So it's just going to be 1, and then everything after it is flipped, which is like that. This one is just going to be normal 1. So the 3 values we've got are -1, 0, and 1. Okay. Then we've obviously, there's going to be 10 intervals. So this is going to be the, you might want to, so you need to label this. So that's going to be the amplitude is this side. And then underneath here, this is going to be the duration. So these are the two, so duration. Okay. we're going to count 10 along, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 10. So then that's going to be 1 in there. So that's 1 second because it says it's just 1 second long. Okay, and then finally we just have to plot the points on there. So the first reading at 0.1 second, because we've got 10 readings, is going to be 0. The next one is going to be -1, so I'm going to go to here and I'm going to put that there. Then what we're going to do is then we've got -1 again, so we've got 4 minus ones. Then we're going to go back up to 0. We're going to go 0 again. I'm just following along here. We've got 1 up at the top, so that's going to go up to there. That's going to go to there. And that's going to go to there. And then what you need to do just to finish this off is you need to connect it up. I don't think mine's going to work, but you need to do a straight line going from all of them. So, I mean, as I said, get your ruler out. So it's a nice straight line. Connecting those up. I can't do it on here because I don't think there's a ruler function. But then you're going to connect those up. Nice straight lines going up there. And that's the end of the paper. I hope that was useful, people. I will put some links in the description if you want to check my website out. We do have some groups, we do have some one-to-one tutoring and all sorts. But if this is just all that you get and this helps you out for your exam, that's all that, you know, that would be brilliant. Hope that was useful, people. Thanks very much for listening.